Okay. In this session, we will be talking about fractionation of recycled fibers for various applications. What happens to the fibers in the recycled paper once they've gone through pressing, drying on the paper machine, and prior to that refining? And once fibers have gone through these operations, they get hardened, or what we call that the fibers have been hornified, and this phenomenon known as fiber hornification. So that when you try to make paper again from these chemical fibers, that you don't get as strong a paper as it was before. You cannot restore the fiber structure like it was before refining, pressing, and drying. So what can we do to improve the properties of the paper, particularly the recycled paper? The options available to the paper makers include refining, fractionation, some form of chemical treatment, or in some cases you can modify the paper machines also. We will primarily focus on fractionation, but just to go over refining a little bit, what can we do to improve the properties of paper via refining? The idea here is to fibrillate the recycled fiber by going through gentle refining and not very harsh refining. Harsh refining leads to less fibrillation and more fiber cutting, which is detrimental to the final paper strength properties like tensile and tear strength and burst strength and compressive strength. So what we want to do is to take the recycled fiber and do very gentle refining so that it results in more fibrillation and less cutting. This is generally achieved by using narrower bar, higher RPM, higher consistency to the extent possible, and somewhat large bar angle to get relatively gentle refining. Here is an example of gentle refining versus harsh refining. And on the x-axis, I have Canadian standard freeness, and on the y-axis, I have ring crush, a mixture of 80% OCC and 20% mixed pulp. When we go through somewhat harsh refining, freeness drops rapidly, but you don't develop as much strength. So we started out with the freeness of about 430-40. Then as you refine it, the freeness decreases and ring crush increases. If you go through gentle refining, you can see that we can improve the properties much more rapidly without too much drop in the freeness. In other words, for a given freeness, we can have much higher ring crush, and that is good for the paper machine productivity. Here is an example of high consistency refining, and by high consistency we mean refining around 30% consistency as opposed to conventional low consistency refining where the consistency is between 3 to 4%. The energy consumption in high consistency refining is pretty high, and the benefits are usually not that much. So only very special conditions we will recommend the use of high consistency refining: when you need stretchable sheet or when you need curled fiber, we would use high consistency refining. When you have too much sheaves in the pulp or too much fiber flakes, high consistency refining might be beneficial. So here is an example or the summary of high consistency refining. It's relatively expensive because you have to raise the consistency of the pulp, so you need some kind of a dewatering mechanism followed by a mechanism to supply this high consistency pulp to the eye of the refiner. Energy consumption is relatively high, but it does preserve the fiber length and give you somewhat higher tear strength. With regard to fractionation, there was a very good editorial in the May 2003 issue of Progress in Paper Recycling that described various aspects of fractionation. Some of the equipments that can be used for fractionation include screens with holes and slots, hydrocyclones, dispersed air flotation that is used in de-inking and washing process. So basically, when we talk about fractionation, we want to see feed stream divided into two fractions, one containing relatively short fibers and other containing proportionately larger amount of long fibers. Why do we want to fractionate like that? The reason is that we can do separate refining of the long fiber, or we can use short fiber and long fiber in different layers of the same board, on a multi-layer board, for example. Alternatively, we can employ long fiber in a liner board and short fiber in a corrugating medium, particularly useful when both liner board and corrugating medium are on the same location. When both liner board and medium are made at the same location, then we can use long fiber in the liner board machine and short fiber on the medium machine. Finally, we would like to fractionate to remove fines and fillers that are maybe not very useful and improve the paper machine productivity that way. So here is one example of the application of fractionation, where you take a mixture of OCC and mixed paper and use the short fiber for corrugating medium and long fiber for liner board. In the case of separate refining, as opposed to refining the whole unfractionated pulp. So here we have the unfractionated pulp at 360 freeness, go through the refining process to reduce the freeness to 280. The tensile strength is 3.7 km and tear factor is about 2.8. However, if I take the same pulp and go through fractionation and only refine the long fiber, so that when I mix it with the short fiber, my freeness is same as before, 280, but now my tensile strength is 4.1 km, tear factor is 3.0, and I have used somewhat less refining energy because I am only refining a smaller stream. And that savings in energy plus improvement in strength properties could justify a use of fractionator in some cases. Another example is when we have a pulp with the Canadian standard freeness of 400 and refine it to 240 freeness using the net energy of about 6 horsepower day per ton, giving you a tensile strength of 5.25 km and tear factor of 8.16. Again, if I go through fractionation and refine only the long fibers to the final freeness of 220 using the same energy consumption, my tensile strength is now 5.45 and tear factor is 8.23. So small benefit of refining separately the long fibers. Another way to fractionate is by using hydrocyclones. When a fiber water mixture goes through hydrocyclone, the underflow contains mostly unrefined, unflexible fiber, so to say, or non-flexible fiber, debris and stiff material, whereas the flexible fibers and fines go through the overflow together with low density contaminants, for example. So in general, you are able to separate flexible fibers and stiff fibers. Stiff fibers go through underflow and flexible fibers go through overflow. Fiber density is greater than that of water. So in general, you will have higher consistency in the underflow and lower consistency in the overflow compared to the feed consistency. Dispersed air flotation is a good way to fractionate the pulp also. In this particular case, fines, fillers, wax and stickies are largely floated out and could be discarded or used for other purposes, and long fibers that are remained can be used for making reasonably good quality paper. So dispersed air flotation can be useful in fractionation. Should point out slight terminology here. Dispersed air flotation used in de-inking versus the dissolved air flotation used in water clarification. Separation mechanism is different in dispersed air flotation compared to dissolved air flotation. Dispersed air flotation is selective separation, whereas dissolved air flotation we want to remove all of the suspended solids from the water. Surface chemistry plays an important role in dispersed air flotation, whereas flocculation coagulation mechanism plays a role in dissolved air flotation. Bubbles are usually quite large in dispersed air flotation, but very small, about micron or thereabout, in dissolved air flotation. Fluid dynamics, we have somewhat turbulence in the dispersed air flotation cell to prevent the fibers from floating out, whereas in dissolved air flotation the conditions is relatively quiescent, so that bubbles can coagulate with the suspended solids and float out all the material. Here is an example of froth flotation used in fractionation. Your yield can be 90 to 93%, and corresponding increase in the compressive strength of the paper, tensile and compressive strength of the paper or burst strength of the paper are indicated here. Bending stiffness also increases by 22%, and macro stickies are reduced by 25% because they have been floated out. Washing can be looked upon as a fractionation because again you can remove fine fillers, wax and stickies, and long fibers are retained. Some question about the definition of fines and the usefulness of the fines. So we say that material that passes through the 200 mesh screen or smaller than 72 micron classified as fines. And we like to identify between the primary fines and the secondary fines, or the so-called dead fines or not very useful fines compared to the live fines or the useful fines. So when you go through the pulping operation, and the amount of fines present in the pulp is what we classify as the primary fines, and those are not very useful in improving the strength properties. After removing the primary fines, you go through the refining operation, and the amount of fines generated are called the secondary fines or the live fines, and those fines are quite useful in improving the sheet strength properties. So you don't want to throw out the secondary fines, they are very useful. So you want to carry out the washing or flotation operation before refining. Remove the primary and the dead fines together with the stickies and other material. Then we go through the refining, and we want to retain these secondary fines as they are useful in improving the sheet strength properties. Here is an example of mixed paper fractionation using the washer. the amount of energy consumed, amount of fines that can be removed by the use of screens or disk thickener or the washer. And finally, the amount of fines remaining in the pulp, and this is the amount of long fiber 48, 44, and 69. Here is another example of mixed office waste fractionation. The amount of fines in the long fiber fraction can be anywhere from 3 to 5%, and the amount of fiber in the short fiber fraction can be anywhere from 7 to 21%, depending on the type of equipment used for removing the fines. If we use the screens versus the disk thickener versus the washer, we can see is the most effective in separating the fines from the long fiber fraction. Chemical treatment to improve the paper properties include enzyme treatment, alkali soaking, starch, or other methods. Enzyme can be useful in improving the strength properties, as they can consume some of the fines and convert it into glucose, for example, and long fibers can be refined and made into paper. Here is an example of the effect of enzyme treatment on unrefined pulp with the freeness of 500 milliliter. When you use refining energy of 200 kilowatt per hour per ton and refine to reduce the freeness from 500 to 400, the same pulp following the enzyme treatment using the same energy can reduce the freeness to 360 instead of 400, or use less energy, 175 kilowatt hour per ton, to go back to the same freeness as 400. In other words, we have energy savings of about 25 kilowatt hour per ton for reducing the freeness from 500 to 400. Here is an example where we use higher energy following the enzyme treatment after refining and so on. So there are various ways of using refining and enzyme treatment to achieve desired result of either energy saving or improving the paper properties. Some people have shown that alkali soaking can help in improving the paper properties. Alkali help improve, swell the fiber and make them somewhat more flexible so that they can conform to the neighboring fiber better and we can get stronger sheet. But there are a lot of other downside to alkali soaking, particularly it increases the effluent COD and BOD among other things. And lastly, some people say that paper machine modification to have an open draw can improve the stretchability of the paper, but we don't have a specific data on that. In general, several ways of including recycled paper properties include refining, fractionation, chemical treatment, and paper machine modification. And primarily by fractionation, we can improve the property by separating the long fiber and short fiber and applying refining to long fibers, and or using the two fractions into separate layer or separate paper products, linerboard and medium, for example. Thank you very much.